I'm starting up the stream. Looks like it is going. Hi everyone, I'm TigerHawk3, and today we're going to do more on the deck. Let me turn off this fan. Okay. Deque in Python. Deque double-ended queue. There's a version in the standard library, but we are writing one for fun. Someone in chat already. Surukun says, hey. Hey. So, today, insert needs to raise an exception if we are at the max length. If self.quantity is equal to self.maxlen, raise value error, I think. Value error, index error. I don't quite remember. It should be it should be what? What am I doing? Decorate its maximum size, index error. Let's just copy this. Great. Raise index error with that. There we go. And Nick M is in chat as well. Says, sup bro, thanks for the cool vids. You are welcome. And Suru asks if I have any exciting plans for Thanksgiving week. No, I do not. I will probably have some turkey, which is not unheard of for me for the rest of the year. I mean, you can find turkey at any time, generally. Turkey slices, cold cuts, turkey franks. I mean, generally not a whole roast turkey is less common, but so this takes care of maxlen, because our append and pop and stuff, append and append left, if you add a new element to a deque with a bounded length and it's already at the maximum length, then it just knocks something out of the other end, and vice versa. But if you put something into the middle, I can't think of anything that would make sense or be intuitive for it to do other than fail. So it will fail, just like the standard library version. In neighbors, underscore neighbors, instead of saying before is this and then return that variable we just made with none and none, we're just going to say that, and then we save a line. Great. In insert, I think we decided that this part isn't necessary. In insert, if not self.first or not self.last. Where was this? Insert? Not self.first or not self.last. I don't really know what that's talking about. Something in this stuff. If before, something like that. But it would just be append or append left, and I don't think it'll actually save a lot. I'm just gonna leave that part. And Cow asks how my week has been. Fine. I found a use for something I bought 9 years ago and had never actually done anything with. I bought a variac and also some rectifiers, capacitors, and resistors, so I could have a variable DC power supply. But I never got around to actually assembling the things to transform AC into DC. So I just had a variac, gigantic thing, kind of heavy, sitting around, and I recently got a fan, and I wanted to turn it down lower than the lowest setting, so I'm like, don't I have something that could do that? Yes, a variac. So I plugged it in the variac, and it works. So that was cool. Anyway, in rotate, I have things that should be unconditional. This line is the same as this one. Self last next, self first prior equals self first, self last. So we will move that over here, unindent it, and move from there. Great, we have saved one line. Both contains method. We're not going to do contains yet. We're going to do more stuff with remove, because I don't want that. I have another plan. Hang on. All right. Chat is talking about ASMR, which is quiet conversation and small noises, generally. So, instead of just saying either one of them or all of them, I will allow you to specify the count. And I'm going to call it count instead of all, because replace in like the string replace calls those arguments old, new, and count. So I'm going to go with count, but that's for replace, and this is remove. So I'm going to call it count equals 1. If count is positive, it will start from the beginning. If count is negative, it will start from the end. And if count is 0, it'll just do everything. Okay, if count is Joe Pano in chat says, OMG, it's Jesus. I do have long hair and a beard. And coding Jesus. I give you the codes, my children. If count is less than 0, I'm going to put spaces over there. Having spaces in that line and many other situations makes absolutely no technical difference to the Python bytecode compiler, but it's a lot easier to read if you put spaces where they're supposed to be, where everyone expects them. Sometimes I see people doing, okay, we're going to have my counter equals 0. Don't do that. Do that. And sometimes they do func with 0 and 1 and this. Now that is wrong. When it's a named argument, you do that. Readability counts. Okay, if count is less than 0, then it, which is the iterator, is going to be self.reviter. Otherwise, it's going to be just the regular iterator. And we're using these instead of the iterator over elements, because we're going to remove the entire node from this Deque structure and you know, remake links. Okay. If count is negative, then we go backwards, otherwise we go forwards. Okay, for each node in whatever iterator we made, if the element matches what we're looking for, if now we need to take the count into we'll need to keep a counter. Counter equals 0. Great. And if we reverse this, we will also make count into its absolute value. So we'll pass in a negative number, and that just says we want to go from the end. But if we have -3, we still want 3 elements to be removed, 3 nodes, not -3 nodes to be removed. That wouldn't make sense. So I've been meaning to do a stream of Euro Truck Simulator 2. Remember I used to do that? I played again a few days ago just to remember some of the keybinds. I have to look in my mouse binds as well, because I remember I remapped some stuff to make it more convenient. But yeah, I've been meaning to do that. I drove some stuff. Or also, I loaded Mini Metro again today because I felt like it, and they've added like 6 or 7 levels. I don't really know the major gameplay difference between each level. They added San Francisco, so I recognize that, you know, land structure with the bays and stuff, so that's cool. I mean, I wouldn't take a train to San Francisco, generally. It's easier to drive, even though it's a long way. The train system around here is not super popular, compared to like Europe and Japan and stuff, where it's bigger. And New York City, that sort of thing. Anyway, we're going to keep a counter. So we have to check whether do we have a count? Okay. Maybe we should do this in an if with break. No. Before we check whether they're equivalent, we're going to say do we have a count? We're going to say either there's no counter, or the current, either there's no count of how many we want, or or we haven't gotten there yet. So if not count, so that means if our count is 0, that means all of them. Or, no, we don't want to replace it all the time. I'll need some grouping, possibly. If either our count is unlimited, or the counter is less than the count, less than or equal to. We will figure that out. For now, let's just do counter less than count. If the count is unbounded, or we haven't reached it yet, and this node has the element we're looking for, we're going to do all this, and instead of this, we're going to say counter plus equal 1. Could be good. Could be good. Let's see now. So, let's step through it in our heads a couple times to make sure we don't have an off by 1 error, because this is a collection of something. It's gonna be full of the potential for off by 1 errors. So let's say we pass a count of 2 for node in iterator. If not count, and if our count is 2, then not count is falsy, because count is truthy, so not count is falsy. Or counter is less than count, and 0 is indeed less than 2, and we found what we want. Let's say we have change all the things, reduce the quantity, increase the counter, so now we have 1 of our counter. And then let's say the next thing is another found element, and chat is being very interesting. We have another found element, so we have the same not counter, counter less than count. That still works. We remove the thing, increase the counter by 1. We don't want to go through the whole thing if we've already removed enough. We'll probably want to break at some point. So once we have found 2 things, if it seems silly to be checking twice. So let's move this from here. Think. As soon as we find enough, we want to stop this loop. JC Api asks in chat, what is an off by 1 error? I've heard it before, but don't exactly get it. That, there's another bug flying around. Fly into the zapper. Come on. An off by 1 error is when you have calculated your algorithm. It works really well, but it does either 1 more or 1 fewer of whatever task you were hoping to do. Like, if you have, example. if you have a program that's supposed to take an input and it says enter your name, and you enter your name, and then it's supposed to print it 3 times, and it prints it 2 times or 4 times. Those are off by 1 errors because they're off by 1. That's the simplest example. In here, it would be, it's often the sort of thing of less than or equal. Because if you have less than or equal, it'll do 1 more. And in this module, we're having a lot of those because it's the entire thing is keeping a sequence of objects and counting a whole bunch, going back and forth and turning it around. So yeah, having a lot of those here. Would it be easier to check if counter is equal to count? This should short circuit the check for that. Okay, yes. So if not count or counter less than count, so when it's 0, it'll work fine. When it's 1, it'll work fine. And then we increase that and it'll be 2. Our example was 2 for a count. And not count, no, or counter less than count, also no, because 2 is not less than 2. It is exactly equal to 2. So this whole thing would be falsy. So something that's false, and it doesn't matter what the other thing is, because it won't work, because one of them was false. If even one is false, then the whole thing won't work. So this should already work. I need some of this stuff, but not that thing. Will that be good? How will we check whether the, let's say if counter is 0. If not counter, then we say it's not there, because this is literally just counting how many times we saw it. If we are within the count and this is what we're looking for, then change it around and say we have 1 fewer thing in this deck and 1 more thing in our counter. So if this is never executed, it will still be 0, and then it means we will have looked through the whole thing and not found it, in which case, not in a deck. Perfect. I like that. That's very tidy. Now we test it. A, B, C, D, E, F, G, H, I, J, K. That's what we have in our decks. Since the remove in a deck doesn't quite work the same way, we could, but we would always have to limit ours with a count of 1, which is the default, but we're going to want to test other stuff. Let's do that. JC says, alright, cool, thanks, no problem. Hope I explained off by 1 errors correctly. The 2 most difficult problems in programming, the 2 biggest challenges, are Unicode, time zones, and off by 1 errors. That's my version of the classic programmer joke. And the original version uses naming things and cache invalidation and off by 1 errors. But I've never really had a problem with those things, as opposed to Unicode and time zones, which are very complicated. Let's do the following. D dot extend bunch of numbers. D.remove. How about something that's not in the deck? 0. This will be an error, and then our program will stop. Let's leave that for last. Let me move that up to the middle of the screen there. How about remove the letter E, and that will be the default of 1. So remove exactly one of them. Print. What did I just do? Print D. D.remove. Let's remove all of the instances of 2. Only one of them, though. What am I doing? For item in E2, I want to change the arguments as well, the other arguments. Okay. E and 1, 2 and 1. Now let's do 2 and the last one. And now how about all of the 3s? Okay. Don't remove star item. What did I just do? What I just did is I made a whole bunch of pairs of arguments that we're going to use. I could have called this args. Would have been a little more standard. It doesn't matter. It's testing. I could have called it tuple, but it wouldn't be a good idea because tuple is a built-in. So it's going to take this first, and this is going to be item. We're going to print our deck that we have, and then we're going to explode or unpack the item, and the first thing will be the first argument, and the second thing will be the second argument. So we're going to remove E, only one of them, that's the default. I think we can actually do this, single tuple, and it will unpack that into one item of E. That should work. We do still need the comma, because if we took out the comma, then we wouldn't have a tuple. We would have the string 2, and it would just be grouped. So you need the comma to say it's a tuple with one item. -1 and 0. Okay. And then do not remove the number 0, which does not appear. It's a number. I don't have any numbers in there. Let's see what happens. Right? Where's the testing? Okay. Command. It should print the deck 4 times, and then a traceback. Oh. Sorry. It doesn't work that way. It printed the deck a bunch of times, and then gave me an error. It's 0, not a deck. This is good so far. It extends about twice as far as this. There's more stuff. That's not so great. I will move it back afterward. I better remember. Okay. First we have a deck with all this stuff, 1, 2, 2, 3, etc. And then we remove E, and only one of them. And we did remove the E. And then we have to remove a single 2. So instead of 1, 2, 2, 1, 2, 2, we'll have 1. And then the first one is gone. And the second one is still there. And then we want to remove the last one, which would be this one over here. And as you can see, it's gone. The 3 and 4 moved up. And then I wanted to move all the 3s. Oh, it prints and then removes. Here's what we will do. Didn't print after the last run. So, there we go. 3, 1, 3, 4. It removed this 2 is now gone, and then it should remove all the 3s. Shouldn't be any 3s in there anymore. I don't see any. And then it said 0 is not in the deck. So that's cool. It works. And guess what? We're going to have a replace that works pretty much the same way. Maybe we'll have a helper function that calls either remove or replace on the things. About that much. That's good. And now I hide it. Good. So we will have something very similar for replace, only instead of this, it's going to be replace the element. So that seems pretty similar. Let's do that. How would that be? Pass it as another argument. I guess we could do that. Let's move it up just a little bit. We'll define let's just call it replace for now. Self item old and new, and count is 1 by default. Let's just make it the same for now. If it's negative, we do this. If it's positive, we do that. And say it's out of value. Start at 0 for each node. Okay, here's where the change occurs. We don't want to mess with the actual node connections. We just want to say the element is different. Equals new. And this has to be old. Simple. And very similar to the remove. So here's what we'll do. Remove replace is going to take self, the choice, and this is not going to be user facing. Let me start it with an underscore. We have self, we have choice, and choice is going to be whether we want to do remove or replace. Actually, can we just have old and new be none or null or something? How will I make a wrapper function for these? Because they have different arguments, as you see. I can just have it be. It doesn't matter, because I will be passing a flag of which one I want. Should I do that? Yeah, because the value we could be removing or replacing could be any value, including 0 or none or whatever. So it's going to be self, the choice of which one we're doing, old, or the item, new, and count, and we will just pass all those explicitly. And we will copy most of this. So for each node, and then they don't need count. They will need either the old and the new. Am I going at this backwards? These are going to have to call remove or replace, and I'll put their should this be a generator? For node in it. You know what? I have decided that I don't want to do this. I just really don't. Rotate, we're going to have remove and replace. They're going to be very similar, but I don't care, I think, right now. I'll think about it for another few moments. Let's see. Call each one, and they can call some main one, which will give us the nodes and check if we're too far. I don't know. I don't think so. I'm just gonna leave it. Maybe between today and the next stream I will realize there is a better way I could do it, which sometimes happens. Then we'll do it another time. But for now, remove, replace, undeck, this is fine. They're just so similar. I guess I would need a another helper function of some kind. Remove and replace would just do nothing but call remove or replace. For node init, these are the same. Just copy the whole thing. Equals item. We'll call it old, and it may remain old if we want. If choice is remove, then we do this stuff. Else, no dot element equals new. Is new a built-in? I don't remember. I don't think so. No. Has no special meaning. It does in Java. Or if you want to make a new dynamic object or something, you have to say like my class, my instance equals new my class. That's just how it works. But anyway, it's new. And remove is just going to call remove replace with what arguments do we want? It's going to say this is remove. And then it's going to pass along the item, and it can say none, doesn't really matter, and the count. And replace will similarly simply call self dot remove replace with replace. It doesn't matter what we chose, it could be anything. Because it just says else. But I'm gonna say replace. And you know what? No, I could have said elif choice equals replace. But I'm gonna leave it as an else. But I am going to specifically, explicitly pass replace over here. Replace old, new, and count. And that is all. Then we can delete this and delete that. So the main thing is remove replace. And that should work the same way. Let's do that. Oh, I can't do this. Can I? Three, 0. What? Should have done remove, which takes these two arguments. And it took it as remove and 0 as 1. That's very strange. Oh, d dot remove 0. Couldn't do that. Oh, it was the last thing. So why did it say 3? One, two, three, 4. initial 1, 2, 3, 4. Okay, good. Let's expand that again. First, remove the E, and it did that. It was here, and now the J has moved. And then remove the first 2, which is here, and only the second one is still there. And then remove the last 2, which is this one, and it's gone. Now it's just 3, 4. And then remove all the 3s. All the 3s. I know what I did. That's funny. Slight scoping miscalculation. I will show you what I did. Item. Do you notice how there's no mention of item anywhere in this method? So it looks for whatever item it can. And the last assignment of item was this, 3, 0. And that's why it does 3, 0. So if I change this, as I should, to old, and save that and run it again, 0, not in Deque. That's a small bug, but still a bug. We don't want it leaking stuff. You really don't. Let's see. Remove and replace are looking good at the moment. Looking good. Should I take something out of the beginning? I already did. I took out the E and it worked. How about the 4? -1. I only want to remove that last item. 4 removes all 3s and then removes the last 4. And the other one is intact. Wonderful. Beautiful. I'm going to comment out these. Replace. Let's test replace. Replace item. Instead of item, we're going to have what are we gonna? I have an idea. Capital E. And only one. I think I can do that. Yeah, I'm gonna explicitly do that because they'll be different. 2, do you know what we're gonna replace 2 with? Capital 2. That's how I roll. And replace needs old and new, not necessarily the count. Old, new, not necessarily the count. So we're just going to leave it as the default. We can actually do that. 2 we're going to replace with at. The last one, 3 we're going to replace with, can you guess what we're going to replace all the 3s with? It's capital 3. Do you know what we're going to replace the last 4 with? I think you know by this point. It's going to be capital 4. Just so you know, the caps lock button does not change the functioning of the number row keys. Doesn't actually make them capital. Like I can turn on caps lock, blah, 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 still numbers, see? That's how that works. replace. Gotta turn that off, or I'm still shouting at Notepad++. Replace 0 with, it doesn't matter, because it's not in there. Now we save. Let's make this a little shorter. Actually, let's take out this 5. How about? And then the whole thing will fit on one line. That's better. Okay. We're going to have a single capital E. Okay. And then we replace a 2, the first 2 only, with an at. It didn't do it. Oh, no, this is the start, and then we replace that with a capital E at the beginning, and then we replace one of them with an at, and then we replace the last one with an at, and then we have, you can't see that. Now you can. This is what we start with. We replace the E with a capital E, and then we replace the first 2 with an at, and then we replace the last 2 with an at, and then we replace all the 3's with the hash symbol, also known as the pound sign or the octothorpe. It is not a hashtag. That's not what the symbol is called. That's how Twitter uses it. It is they indicate tags by using the hash sign. Just so you know, never call this a hashtag. Place all the 3's with hash. There's one. Great. And then we replace the last. We replace all the 4's with -1. Did I do that? 4 and -1. All of them. What is that? 1, 3. What does this last one do? Does it do anything? Oh, yeah, there's a 4 replaced with -1. And by default, it only did it once. So this was a bug in my testing, but it still did what it should have. It wasn't testing what I thought it would. Didn't I put $1 in there? Pretty sure I did. Oh, it must have been when I typed other stuff and then did undo. So let's do that and run that again. Now replace the last 4 with $1 instead. Whereas here we had the first 4 was replaced by a -1, and now instead the last 4 is replaced by a $sign. And then we try to replace 0, and it says 0 is not in the deck. So you can't get eFlask. And that is a reference to a Homestar Runner animation. Strongbad is talking about different kinds of video games, describes sports things and RPGs and whatnot, and the text adventure games where it says, you know, you walk into a room, exits are north and east, there is a flask in front of you, and so you just type in get flask, and then for some reason it says can't get eFlask. It's not going to tell you why, but you just can't. Can't get eFlask. Anyway, these are very nice. I'm happy with that. What should we do next? Rotate, replace, remove. We did those. Those are great. Should we do a contains now? It's been 55 minutes. Let's do that. Let's do that. Derivative reverse. Let's just stick it on here. I don't know. Contains. What does this method do? This method will return a boolean that tells us whether our collection, our deck, contains some particular item that we pass it. I need that part. And the starting and ending with double underscores, this particular name of something, double underscore contains double underscore, is actually called by the interpreter when someone writes whether item in my deck. So, like if 3 in D, and they would just write this, and it would actually call this contains method automatically. You could also do if D dot contains 3, but don't do that. Notice how much shorter that is? Yeah. So this is going to be for element for node in, actually, let's just do element in self, and that'll iterate and find the elements because we don't want to change the structure of it. We're just looking through it. For element itself, if element is equivalent to the item, return true. And if we get to the end without success, we will say return false. If you don't write this contains method, the interpreter will by default just try to index through everything, which if you have like a list or something, then indexing is kind of just as fast, starting with 0 and up, right? It's not too bad. But for a deck, it would not be just as fast, because the 0th is found immediately, and then the item in index 1 requires you to go through 0 and 1, then you go through 0, 1, 2, 0, 1, 2, 3, and it gets very slow very fast. So if you have a more efficient way to look through it, then you do that, and you provide it here, which we have done. And now we'll do this. At this point, what do we have in here? We have some letters. How about we'll do print A in the deck. Print 1 in the deck. Let's look in the beginning and the end also. How about 2, 6, 3, and 4. And $sign. Print I and D. Great. Now I turn this back on. E is at the beginning. Lowercase e is still... Is it in there? No, it is not. It really isn't. Okay. Okay. Here's our capital E. So this is the stuff we're looking for, including the $sign. So we want capital E, and it's there, so we have true. Lowercase e is not in here anymore, so that's false. Then 2 and 6 should both be in there. Here's a 2, here's a 6, so those are true. And 3 is not in there. Remember, we replaced them all with the hash, so they're gone. They're all gone. They're all gone. And 4 and $sign are both in there. Here's $sign, and here's 4 in the middle. Great. Alright. I'm just gonna leave that moved to the side. So that works. Actually, let me, I am gonna put it back. There we go. Contained, we got all that stuff, and that took all of, like, 6 or 7 minutes. Some things are easier than other things. Like the get neighbors and the insert and the rotate, those were crazy. Crazy. Rotate is actually pretty short. Now that, with get neighbors, that's not get neighbors. Neighbors. Obviously it gets them. Remove or replace. The remove replace is anything, and it does all the stuff. So we either remove or we replace. Oh, this shouldn't be here. This should be up here. Oh goodness. What was that doing? That was reducing the quantity. Used in rotate and insert and neighbors and index, things we weren't doing. Clear, pop, we weren't actually doing those things, so we didn't get to an error. Good thing I noticed. We only want to reduce the quantity if we're removing the node that contains this element. Otherwise, we don't want to do that. Otherwise, we just say replace that element, because we're replacing it. And in either case, counter has to go up by 1, because we have found one more instance of it and acted accordingly. What else are we doing? What else have we got? We got a bunch of stuff. Contains, remove, replace. Will there be any other things with count? I don't think so. Let's look at the official documentation for a deck. Append, append left, clear, copy, count, extend. Yeah, count is definitely already there because we had to change self.count to self.quantity. Extend, extend left, index we already did with the start and the stop. I believe. Should be somewhere here. Index. Insert, yes, definitely. Pop, pop left. Remove a value. We did that today. Reverse, rotate, maxlen. In addition to the above, Deque support iteration. This does. Pickling, I checked and it does. Len of D, which it does. It's somewhere in here. it's the quantity. That's what it is. Reversed, and it does with the double underscore reversed method. Copy.copy, I think those work. Yeah, I mean, it's just copy.deepcopy, etc. Membership testing with the in operator, that's the contains. And subscript references such as d square bracket -1. So we will we will do that. Next time, starting in version 3.5, Deque support add, which we have, mul and imul. Mul, mul is the multiply when you have one object times another object with the asterisk or star. And Deques, similar to strings and lists and stuff, support multiplying by an integer, and then you get the sequence repeated that number of times. Like the string hello times 0 is the empty string, hello times 1 is hello, hello times 2 is hello, hello, and so on. Hello times 1.5 crashes. And hello times hello also crashes because what in the world, right? So, next time we will do an operator. Indexing, slicing. The standard Deque does not support slices. Ours will. We will try. Indexing, slicing, and mul and imul. And imul is when you have some object or some name times equal, just like the plus equal would be I add. What actually happens? D times equal to, and D did not change. What does that even do? I have no idea. I really don't. They support imul. Am I doing the wrong thing? I don't think so. Finally, sequence type should implement addition, meaning concatenation, and multiplication, meaning repetition, by defining the methods add, radd, iadd, mul, rmul, and imul described below. These methods are called to implement the augmented arithmetic assignments. I don't know what this does. Like, what is... I can show you what's going on and why I'm confused. I have D. D times 2 is... what in the world? That doesn't change anything? Oh, it has a maximum length. That would be it. And there's no error. It just doesn't work. Okay. What happens if we do d equals collections.deque ABC max len equals 4. Here's our d. D times 2. That's odd. It did A, B, C, A, B, C. And so the first A and B disappeared. So it's just appending, I guess. That's fine. How did I implement extend? Is it a bunch of appends? Extend, yep, it's a bunch of appends. So it'll be the same thing. D is still that, D times equal to, D is now that. Okay. Those shouldn't be too hard. We'll just have for I in range count. For we'll have to make a copy. Other equals self.copy. And then for I in other, d.append I. And that's for the times equal. Didn't get it this time. For the regular d times number without the augmented assignment, I would just have a temporary one and do that. Or you could just make a bunch of copies and say the first and next are together. I don't know. Or copy and extend. Yeah. Anyway, that is for next time. Indexing, slicing, mul and imul, and at some point we will also do things from the data model. What do we got? I wanted to do rich comparison, which is the less than or equal to, not equal to, greater than or equal to. You can do these with strings, lists, that sort of stuff. And they're lexicographical, basically, meaning like alphabetical order. Or if they're not alphabetical, it'll try. Like you could have the string A being less than the string B, and if two matching items from two lists or whatever are the number 2 and the number 3, then 2 is less than 3. And it evaluates everything as words, basically. Of course, meaning the string 10, 0, is smaller than the string 2, because 1 is before 2. Just like any word that starts with A is before any word that starts with B. Those are for next time. Rich comparison. Okay. I think mul and imul will be easy. I'm going to move that to the top of my list. Indexing and slicing, possibly not so much. Rich comparison, I don't know. But mul and imul should be pretty doable. So, what's in my copy method? Return. Okay, that's easy. And that just uses append internally. Fine, great. This time we changed insert to raise an exception if we're at the max length. We changed creating a before variable and then immediately returning it to just directly returning what it would be. We didn't change insert, we changed rotate to move an unconditional thing outside of both if statements. We did contains, we did replace, and we did remove, which are slightly more versatile than the standard ones. Because instead of replace doing only one substitution and exactly one, it will by default do one, but you can have it do however many you want. And actually, is there a replace? I think there's only remove. Yeah, the regular deck only has remove. So we did remove as well. So remove, instead of just removing only the first occurrence, it can remove any number starting at either direction, or all of them that it finds. And same with replace. With strings, there's no need for remove, because it's basically replace with nothing. But for this we have a container for each item, so it doesn't quite work like that. We have replace, we have remove. That's all we did today. Next time, mul and imul. Indexing, slicing, rich comparison, I don't know how much of that will get done. But we did a bunch today already. Previous segments of this series are on my channel. The code, as always, is on GitHub in the small scripts repository. The link is in the description. I will push these changes today after the stream. And remember to like, comment, subscribe. And I hope you enjoyed the video. And I will see you next time. Have a good one.